what's your function?
My function, I guess, eat, sleep, and play games.
Well, I'm not asking you what you like to do. Look, if this box is you, and I input food and rest into the box, what would the output be?
Let me think. If I eat, then I will go to the toilet. And that's where there will be an output.
Well, that's one possible outcome, but another possible output could be that you'd have lots of energy and you'd be able to do productive work, like completing all my assignments.
Okay. And so your main point would be?
It would be to illustrate to you the concept of functions.
So that means I'm the function in this case.
That's right. Mathematically, a function is a process that associates each element of a set X to a unique element of a set Y, meaning given a specific input, a specific output is produced.
So does that mean if I'm the function and the input is videos like this, the output would be A+ in my exams?
That's a very good example. And instead of writing or using the word function all the time, we mathematicians thought of two ways to represent a function. The first is to use f bracket x to represent a function, but we read it as f of x. For example, f of x equals x squared. This is a function that links any value x in the input set to its square number in the output set. In other words, a function describes the relationship between input and output. You can call it the process if you like. Now, for the second way of representation, the arrow with a vertical line means mapping. This means any value of x will be mapped to the square number of itself. In both cases, f is the name of the function, x is the input variable, and x squared is the process done to the input variable to get the output. And it doesn't have to be f of x all the time. You can name the function in your own way. For example, h of t equals t cubed plus 1.
Okay, but the first notation, f bracket x, looks like f times x.
That's a common misconception. The first notation actually refers to a function f of input x. You can't multiply them together just because they look like two variables.
I understand now.
Then can you tell me whether f of x equals sine is a function or not?
I don't see the variable x on the right side of the equation. So it's probably not a function?
Excellent. It's not a function because it doesn't have any variable to show the input. The right way to write this function is f of x equals sine x.
Finding this helpful? We have additional learning resources to offer. For Cambridge IGCSE and AS A-level subjects.
We mathematicians can be quite lazy and sometimes we use a single alphabet to replace a function name. So in this case, y is equivalent to the f of x.
I understand that f of x and y can be used interchangeably. But generally, f of x is preferred because we can directly know from the representation what the input variable is, right?
That's right. In addition, mathematicians have given names to both the input and output set.
And what are they called?
Let's look at f of x equals 2x. If we select the input set to be the set of all natural numbers, then we know that the output set will be 2, 4, 6, 8, and so on, which is the set of all positive even numbers. Then the input set, which are all natural numbers, is called the domain of the function f, which we write as capital D with subscript f. The output set of all positive even numbers is called the range of the function f, which we write as capital R with subscript f.
Teacher, will the domain of a function always be natural numbers?
Of course not. The domain is the set of all possible x values which will make the function output real values.
Any examples?
Let's look at f of x equals 2 over x. When we input some x values, for example, if x is equal to 1, then f of 1 will give us 2. And if x equals pi, then f of pi will give us 2 over pi, which is a real value. However, if we attempt to input x equals 0, then the output will be 2 over 0, which is undefined.
What do you mean by undefined?
Well, when you divide 2 apples by 0, how many pieces of apples do you get?
2 apples?
That can't be, because 2 divided by 1 then is equal to 2.
1 apple?
That can't be, because 2 divided by 2 then is equal to 1.
0 apples?
That can't be too, because the apples can't possibly disappear.
Oh, that's why 2 divided by 0 is considered as undefined. Got it.
So, for this situation, the domain of f is the set of all real numbers except 0. This can be written as such. The vertical line in the set means such that.
Okay.
Once we have the domain of the function, the range can be derived easily from the domain set. In this case, the range of f is all real numbers excluding 0, since 2 divided by any real number except 0 gives us a real value.
So, none of the real numbers results 0 as an output?
Correct.
That's much clearer.
How about finding the domain of h for h of x equals square root of x minus 5?
Okay, let me see. Since the function is the square root of x minus 5, we need to make sure that the square root of x minus 5 produces real numbers only and not undefined numbers. I know that the square root of positive numbers are all acceptable. I know that the square root of 0 is also acceptable. But the square root of a negative number is impossible because negative numbers are only produced when a negative number is multiplied by a positive number. Hence, the expression inside square root x minus 5 must be greater than or equal to 0. Solving this inequality will give us the domain as x is greater or equal to 5, which can be represented as the set of all real x values, such that x must be greater or equal to 5.
Register now for free.